Hello everyone, welcome back to Cambridge Guru. We are doing chapter vectors and we have already covered in the previous lesson intersection of two lines in vector form. Next topic is angle between two lines, right? So now as far as angles between two lines is concerned, it is just like finding out angles between two vectors, right? Why I'm saying this is because let us say we have been given a line which is vector r of the type 104 plus lambda times 2 minus 1 and 1. Let us call this straight line as line AB like this. Okay. This is line AB and there is some origin in this. So we have a position vector OA and position vector OB and we find the equation of line AB, right? We call this point A as a position or the location vector and this AB as the direction vector, right? So as far as equation of a straight line is concerned, we have already done this, that we call this as the location vector and we call this as the direction vector, right? So whatever is the direction of this direction vector AB, that is the same direction of the straight line or the vector line, right? So this is our line which is lying along the direction of AB. That's why we call this as a direction vector which gives the direction to the given line, right? Similarly, for another line, let us denote this by this green color, like this. Let us say it is going in this way downwards and this is CD, right? So there is a position vector C, there is a position vector OD and there is a line which is joining these two position vectors C and D, right? So whatever is the direction of this direction vector for corresponding to the second line means I'm talking about this direction vector and this is the location vector, right? So that will be the direction of the straight line CD, right? So if you have to find out the angle between these two given lines AB and CD, meaning is we have to find out the angle between these two direction vectors, right? So that's why I said at the starting of this that it is just like finding out the angle between two vectors. We just have to find out between which vectors we have to find out the angle, right? So it is the direction vector of a straight line between which we have to find out the angle, right? So this question now reduces to finding out the angle between two vectors given by 2, -1 and -1 corresponding to straight line 1 and 3, 0 and 1. Okay, and as we have already done in the previous lessons that how to find out the angle between two given vectors using the scalar dot product, right? So it will be cos theta is equal to dot of, let us call this vector as AB and CD, not modulus, right? So AB vector dot CD vector divided by AB modulus and CD modulus, right? So this is your AB, this is CD. So taking the dot of these two, I'm writing this as 2 into 3 is 6, -1 into 0 is 0 and -1 into +1 is -1 over mod of AB will be 4 plus 1 plus 1 means 2 square plus -1 whole square plus -1 whole square. This is modulus of AB and then multiplied by modulus of CD which is 3 square plus 1 square. Okay, so this is your cos theta. So cos theta is 5 over, this is 4, this is 1 5, this is 1 6, so root 6 into this is 9 plus 1 10, root 10. So this you can write as 5 by root 60. So theta will be cos inverse 5 over 60 under root, whatever is the value. Okay, if I use my calculator, so this will come out to be approximately 49.8 something, okay, degrees, right? Simple. Okay, so angle between two lines is same as finding out the angle between the direction vectors, right? Let us take another question. It says that the points A and B have position vectors related to the origin, these OA and OB. The line L, there is a line L which has a vector equation like this. Okay, we have to show that this L does not intersect the line passing through A and B, right? The last lesson, if you have to find out the point of intersection, or whether to find out whether the given line is intersecting the given line, or whether two lines are intersecting or not. So the last lesson was about intersection of two lines. Okay, so if you haven't watched that video, please go through that, right? So in that concept, how to find out point of intersection, or how to find out whether the lines are intersecting or not. So in this question, let us find out first the line passing through A and B, right? So it is just like finding out, this is your location vector you can take, and finding the vector AB. Okay, AB vector. It is just like OA plus lambda times AB we are finding. Okay, so AB vector is OB minus OA, right? Which is 2 minus 1 is 1, 1 minus 2 is minus 1, and 3 minus 3 is 0. Okay, this is your AB vector. So vector equation of the line passing through A and B, vector equation of a line passing through A and B is given by OA, which is 1, 2, and 3, plus lambda times plus 1, minus 1, and 0. Okay, so this is the line passing through A and B, and this is the line which is line L. We have to find out whether this line L is intersecting this line, right? So how we do this? Write this as combining the I, J, and K component, writing this as 1 plus lambda, this is 2 minus lambda, and this is 3. Okay, so this is a position vector of any general point which is lying on the line AB. That is the meaning of equation of, or the vector equation of a line. Okay, so this is the position vector of a point which is lying on AB, and this is the position vector of a point which is lying on line L, right? So suppose we have the given line AB as this, and the second line L is going through like this, right? And they are intersecting at this point. Okay, let this point of intersection is M. Okay, so if these two lines are intersecting, that means their position vector at this point M should be same. Okay, so we are assuming first that, let us assume that these lines are intersecting, and if they are intersecting, then this position vector R of AB and this position vector, that should be same. Meaning of this same means the x, y, and z component, they all should be equal to each other if they are intersecting, right? So we will derive, or we will follow this step, that if they are intersecting means there is a point, and if there is a single point for both of these straight lines, that means the position vector is same for the given two lines at that point of intersection, right? So we can write this equation, this vector R, which is representing the equation, the line L, as 1 minus 2t. In the column vector I am writing 5 plus t and 2 minus t. Okay, so this must be equal to our 1 plus lambda, 2 minus lambda, and 3. If they are representing, again I am repeating so many times that these are same points. Okay, and if they are same, so let us equate the third, means the z component, that 2 minus t must be equal to 3. Okay, so here I am getting 2 as t as minus 1, right? If t is minus 1, putting this in the second equation means 5 plus t must be equal to 2 minus lambda. If t is minus 1, this is 4 is equal to 2 minus lambda. That means lambda is equal to minus 2. And if lambda is equal to minus 2 and t is minus 1, both these values should satisfy the I component, right? That means 1 minus 2t must be equal to 1 plus lambda for these lambda and t. So putting t equal to minus 1, your LHS will become 3. 1 minus 2 into minus 1 is 1 plus 2, which is 3. And your RHS will become 1 minus 2 is minus 1. So as you can see that the I component or the X component, they are not equal. And if they are not equal, we say that these are not the valid values of lambda and t, which will satisfy all the three components, means x, y, and z. That means they are not representing the same point of intersection. That means they are not intersecting. Okay. So this is your first part, the working of part 1. Now, second part says that the point P lies on straight line L and is such that PAB is equal to 60 degree, right? So let us again draw this straight line AB. This is your AB, and there is a point P which is lying on the line L. Let us suppose this is your straight line L. Okay, and this is point P such that this PA and this is PB, that angle PAB is equal to 60 degrees. This angle is 60 degrees. Okay. So it says that given that the position vector of P is 1 minus 2t, means since it is lying on line L, so it will be of the type line L. Okay, 1 minus 2t, 5 plus t, and 2 minus t. We have to show that this equation holds true. Right, so if this condition is satisfied, that P is lying on line L and this angle is 60 degree, then this condition should be verified. Not verified, but this condition should hold true. Okay, and then we have to find the only possible position vector of P. Okay, so for this what we have to write, the condition is that angle between PA and AB is 60 degrees, right? So first find out this position vector PA, which is OA minus OP. Okay, not okay, OA minus OP, right? We have OA vector as this 1, 2, and 3. This is equal to 1, 2, and 3, and OP vector is this one, right? Position vector of P is given as 1 minus 2t, 5 plus t, and 2 minus t. 5 plus t and 2 minus t. 2 minus t. Okay, this is the position vector of PA. So 1 minus 2t, this will be 2t. 1 minus 5 plus t is minus 4 minus, sorry, 2 minus 5 plus t is minus 3 minus t. Okay, and lastly 3 minus this will be 1 plus t. This is your PA vector, right? And AB vector is again will be given by the line joining A and B, and AB vector is this one, 1 minus 1 and 0. Okay, this we have already covered, already calculated AB vector, right? So cos 60 now is PA dot PB, not PB, it is should be AB. Okay, PA and AB. So dot AB over mod of PA into mod of AB, right? So let us put the value of cos 60, which is half, is equal to PA dot AB. So this is your PA 2t and this is minus 1. So if you take the dot of this, you will get minus 2t. Minus 3 minus t into 1 is minus 3 minus t, and this is 0. Okay, this is PA dot AB over mod of PA. So this will be 2t whole square plus minus t whole square plus 1 plus t whole square. under root, okay, into mod of AB. Mod of AB is 1 plus 1 under root, right? So you will get your numerator as minus 2t minus t is minus 3t minus 3 over, let us simplify this, denominator it is 4t square plus this is 9, this is plus t square, and this is plus 6t. Okay, this minus you can take outside, it will become 3 plus t. Okay, this minus you can take outside, it will become 3 plus t, and then you can square this, so minus will become plus, so it will become eventually 3 plus t whole square, which is 9 plus t square plus 6t, right? And this is 1 plus t whole square is 1 plus t square plus 2t, okay, under root, and into root 2. This is your LHS, which is half. Okay, so let us quickly simplify this. This is 1 upon 2 equal to minus 3t. Okay, let us cross multiply. Okay, let us cross multiply. Okay, let us first simplify this. So 4t square and t square is total 6t square. Okay, this we have calculated. Then in order to avoid confusions, I can cancel these out. Okay, this has already been counted, 6t square. Then how many t's are there? There are 8 t's. Okay, so writing this as plus 8t, this is already done. And then we have 9 plus 1 is 10 under root and into root 2. Right, now squaring both the sides, okay, you will get 1 by 4 is equal to, I can transfer this after squaring, this will become 2, and this 2 can be transferred in the LHS, so 2 by 4 will become 1 by 2. Okay, so I am writing this as 1 by 2 is equal to, now I am squaring, it will become 9t square plus 9 and plus 3 into 3 is 9 into 2 is 18t over 6t square plus 8t plus 10. This implies cross multiplication. You will get 6t square plus 8t plus 10 is equal to 18t square plus 18 plus 36t. I am not sure I will get the right answer, but essence of the method is important. So 18 minus 6 is 12t square. Okay, this has been counted. Then how many t's are there? 36 minus 8 is 28. So plus 28t, and 18 minus 10 is plus 8. I think I have got the right answer. 4 we can take outside. So this is 3t square plus 7t plus 2 is equal to 0, and I think that is the required condition. Yes, 3t square plus 7t plus 2 equal to 0. Okay, now if this is equal to 0, let us find out the value of t. Okay, so 3t square, you can factorize this as t plus 2 into 3t plus 1 equal to 0. Okay, by splitting the middle term, I get these. So t value you are getting as minus 2 and minus 1 over 3. Okay, so it says that hence find the only possible position vector of P. Only possible means out of these two values, position vector of P is in terms of T, right? For two values of T, you are getting two values of P, right? Since you are getting two values of T, that means position vector will also be 2, but that is not the case, right? We have to eliminate one T, or one T is not acceptable. So which value of t is acceptable, and that is the only value for which it is asking the position vector, right? Only possible position vector of p. So how to choose these two values out of these two values? Okay, so let us take this minus 1 by 3 because it is in fraction. So I am little bit, not optimistic for this value of minus 1 by 3 that it will hold true. So let us test for this minus 1 by 3. And what we need to test is, we need to find out this cos 60, means angle formula, right? What angle formula? See this diagram, that if I take t as minus 1/3, so will the angle between PA and AB will be 60 degree, right? So if t is minus 1/3, let us find out PA. Let me take another color. So PA, I'm choosing if t is minus 1/3. So what the vector is PA? PA is 2t, right? So it will be minus 2 by 3. Let me write here only. This is minus 2 by 3, minus 3 minus plus 1 by 3, right? And 1 plus t is 1 minus 1 by 3. So PA vector will become minus 2 by 3. This is minus 3 plus, so this is plus 8, minus 8 by 3, and then 2 by 3. This is PA, right? So PA dot AB, and AB vector is 1, minus 1 and 0. So if you take out the dot product for this, you will get in the numerator as minus 2 by 3 and plus 8 by 3, right? Means in the numerator we have PA dot AB, right? And whatever is the denominator, right? So if you find out PA dot AB, what you will get is minus 2 by 3 and plus 8 by 3. Minus 2 by 3 plus 8 by 3, right? So it is minus 2 by 3 plus 8 by 3 is whatever is the value, it is not, cos 60 is half. It won't be half, right? It is 2 and there is something here in the denominator, right? So you won't get the, I think this value will be negative. There is some calculation mistake in finding out this, right? So whatever my point is, that cos 60, which is half, if you take the dot product of this, you will get the negative value, right, for corresponding to minus 1/3. So you will reject this minus 1/3 and you will accept t equal to minus 2. Okay, so thing is, out of values of t equal to 2, you just be alert and just satisfy, because it was mentioned in the question that you have to reject one, right? Otherwise it is not required to be that smart that it is not us, and then also we are eliminating or checking whether we have to eliminate or accept one, right? Since in the question we have to reject one value, so using the condition of this angle cos theta, that will decide that which value will be accepted and which value will be rejected. Okay, so I think this is all for finding out as far as angles between two straight line is concerned. I hope you enjoyed the video. Next video will be the last topic, finding out the shorter distance from the point to a vector equation, or to a line, okay, given in vector form, right? So till then, see you soon. Bye bye.